One important topic that we don't talk about often in statistics is normality tests. And we do a lot of things with normality tests. So if I'm going to run these next kind of inferential statistics tests that we're about to cover in the next section, I need to know if the data is normally distributed or if it's not. So you'll often hear it as normal data, normally distributed, or parametric data. There's a huge way in how you run normal data versus non-parametric data. It's massive. I mean, it's the crux of the way you'll go down to these tests. For the first part of the next section, we'll look at normal tests or normal tests that use normally distributed data. In the last part, I'll go ahead and talk about some non-parametric tests. So when you're working in the real world, when you see your data, you'll decide, is it normal? Is it not? This is the test I run. So normal tests can determine if the data itself is normally distributed or not. Minitab can make a graph and test for normality, and the test that we use is called the Anderson-Darling test. So when you're using the Anderson-Darling test, what it does is it graphs the data on a normally distributed line, and it's going to be a straight line. It's not going to be that curve because you think about you're looking at the data from the top down, like the data is under you and you're looking down at it. So the hypothesis for the Anderson-Darling test is your null is that the data follows the normal distribution, and the alternative is the data does not follow the normal distribution. So we're going to use the fat content data. We saw that again in module 1, but I'm bringing it back for this one. So a scientist for a company that manufactures processed foods want to assess the percentage of fat in the company's bottled sauces. The advertised percentage is 15. The scientist measures the percentage of fat in 20 random samples. The previous measures found that the population standard deviation is 2.6%. Okay, I'm not worried about what they're looking for. I'm just looking to see if the percentage of fat data is normally distributed. So my hypothesis is the percentage of fat data follows the normal distribution. The alternative is the percentage fat data does not follow the normal distribution. So what I'm going to do, I'm going to get out of here. I'm going to go to my data set. And again, you will find these in the module that you're in, the data set for that. So I've downloaded it to my computer. And when I do that, Minitab automatically opens up for me. So again, on the PowerPoint, I have the steps that you need, but I'll walk you through them. I'm going to go to Stat, Basic Statistics, and down to Normality Test. I click on it, and again, I want the percentage of fat. The default is the Anderson-Darling. Just go with that one. That's the one we're going to do in this class. There are tons of different normality tests. This is the main one, and it's the easiest to understand. So I hit OK. And it brings me this pretty graph up. And as you can see, a lot of the dots are on the line. There's a couple that are off the line. It gives me the mean, the standard deviation, the sample size. It gives me the Anderson-Darling value, and it gives me the p-value. Okay, that Anderson-Darling value is something we want to talk about because I want to put it in when I write it up. And I've got my p-value that I also need to use. Okay, so let's go back to the PowerPoint. I have everything I need. And if you go back to the PowerPoint, you'll see that I have that on there. All right, so when I write it up, what I want to do is I'm going to put that in there. Hold on, I'm going to add the Anderson-Darling value just so I have it in there. Okay, we're going to call it AD. So what I'm doing is I've got to use the Anderson-Darling value for my results, but I also have to put in my p-value. So let's go back and look at the graph. Okay, again, we can see most of the dots fall on the line. So since my p-value is 0.463 and it's larger than my level of significance, I'm going to reject the null, which means my null is true. And if I go back to my hypothesis, remember, it means the data follows the normal distribution. Because I kept my null, then that means it is normally distributed. So here's a way to say that. preliminary analysis shows the data set for the percentage of fat to be normally distributed as assessed by AD. And in the industry, we know that's an Anderson-Darling, which is this, and a p-value of 0.463. That's how you're going to write it up. You told me that you ran an Anderson-Darling test, you gave me the value, and then you gave me the p-value. That's how you do that. So our steps were you made your hypothesis, you ran the test, and now you're concluding the test and you're writing the final analysis. All right, so let's look at another data set. So using the antacid reaction time, a chemist for a pharmaceutical company wants to determine whether the mean reaction time for newly developed antacid is less than 12 minutes. The chemist measures the reaction time for 16 samples of the antacid. We're going to see if the antacid reaction time data is normally distributed. Okay, again, go find the data, and I have it here. I'm going to open it again. When I click on it, it opens a mini tab. And here it has the time. So I'm going to go up to stats, basic stats, normality. I'm going to put the time in there, and I'm going to keep the Anderson-Darling. So then I'm going to look at it. All right, this data kind of looks weird because look, that's on the line, that's on the line, that one's on the line, that's close to the line, but they're not really all on the line because look, if I hover over this point, it shows me what row it is and what value it is. And I have a lot of stuff that's not on the line. It's kind of a weird thing. If you look, it almost like it went there, went across, and went there. So something's going on with this data. So I'm going to go back to the PowerPoint so you can see it again. So if I look on here, I've got this, and I'm not showing a lot of points are on my line. And again, I should have backed up. I have my hypothesis. I'm running my test. So again, I've got that. I'm going to go to my Anderson-Darling value. My Anderson-Darling value is actually larger than it was last time, but my p-value is a lot smaller. So since my p-value is 0.014 and it's less than the level of significance, I'm going to reject my null, which means my hypothesis is false. So if I go back up here, what I'm saying is this one is false and this one is true. So again, it's showing my antacid reaction time doesn't follow the normal distribution. Well, that's a huge deal because that's saying, okay, this is not normally distributed and there's different ways I have to handle it. So again, what I'm going to do is I'm going to fix this and I'm going to put by AD or AD equals, and I'm going to put the Anderson-Darling value because I want to make sure I include that and the p-value. Again, it's kind of closing the loop so that if I publish my work or I present my work, I'm showing that I have my statistical background from it. So for this data set, preliminary analysis shows that the data set for the antacid reaction time is not normally distributed, as assessed by an AD of 0.927 and a p-value of 0.014. And in conclusion, okay, remember, if the p-value is greater than the level of significance, you're going to keep the null, which means the data follows a normal distribution. If your p-value is lower than your level of significance, you're going to keep your alternative, which is the data does not follow the normal distribution.